Hi, Mr. Pierce here again. We're going to be investigating the transformations of curves, and we're going to look at f of x equals x squared again. And this time we're going to multiply inside the brackets by minus 1 and remind ourselves what happens graphically when we do that. So what I've done is I've taken my input x and I've multiplied it by minus 1, and I therefore get minus x all squared. If you remember, this particular transformation, when we multiply inside the brackets by a number, corresponds to a stretch of scale factor 1 over the number that you multiply by, and in this case we're multiplying by minus 1, so it's scale factor 1 over minus 1, and that is in the x direction, so it only affects the x part of the coordinate. Of course, we could simplify this because 1 divided by minus 1 is in fact just minus 1. So let me just get rid of this. Oh, sorry about that. And write minus 1 there. So what should happen here is that the x parts of these coordinates should each be multiplied by minus 1 for this particular transformation. Before I look at that graphically though, it's probably a good idea to just look to see what's going on with this, because f of minus x is of course minus x all squared, and minus x times minus x is actually positive x squared. So in this particular case, when we multiply the input by minus 1, the output's actually exactly the same, so this transformation isn't going to show us anything at all for this case. So we're going to have to look at some different cases to see if this is actually correct, whether it is a stretch of scale factor minus 1 in the x direction. So let's get on to GeoGebra, and as you can see there, hopefully, I'll just pull this up a bit, I've put in the equation f of x equals e to the power x, similar to the last video. So if I press enter there, then I've got my equation on the graph. Now, if I enter f of minus x, multiplying the input by minus 1, then let's just analyze what happens when we do that. So, as we said before, what should have happened is that the x parts of these coordinates should have been multiplied by minus 1. And that seems to have happened because if you look here, we've got 2.7, about, not exactly 2.7, but about 1.2.7, and that's gone to minus 2.7, to, let's say, to 7.4, let's say, 7.5, has gone to minus 7.5. So the x parts of the coordinates have been multiplied by minus 1, and the y parts of the coordinates are unchanged. However, you might notice that there's a slightly simpler transformation going on here. If I look at e to the x and the transformation that's gone on, it looks as though e to the minus x, so f of minus x, is a reflection in the y-axis this time. But again, that's quite difficult to see, so I think I'm going to pick another function to see if this is the case for. So let me just get rid of these, and let me draw in another function. Let's have f of x equals log of x. So there's f of x equals log x. And again, if I type in f of minus x, hopefully that will be a reflection in the y-axis. So if I press enter, that is a reflection in the y-axis. Yes. So if I go back onto Paint, then this stretch of scale factor minus 1 in the x direction is correct, but that is the same as a reflection. Oh, sorry about that. In the y-axis. Okay, so now we've completely done with transformations, and the next video will just be a complete summary of all the previous 6 videos. Thanks a lot, I hope that helps. Bye!